Hey guys, welcome back. Let's talk all about what we learned in exploratory factor analysis and really the links that led us to be able to start this topic, which started with our understanding of the level of measurement, then from correlations, and then building into factor analysis, which summarizes correlations amongst items and common clusters that form factors. And so the steps that we take for an exploratory factor analysis was check the assumptions, ensure that the assumptions are met, choose the extraction method and rotation to best fit the data, determine the number of factors based on examination of eigenvalues, scree plots, percentage of variance explained, select the items based on the factor loading. So you have your loadings and you want to ensure that you're selecting the items that allow you to have the cleanest factor structure, and then naming and describing factors. So looking at the items, seeing what factors they load onto, how they cluster together, and how we could best name that factor. And then creating composite scores to examining correlations amongst factors, analyzing the internal reliability through Cronbach's alpha, and then computing composite scores to use factors as subscales. And so all of these steps are really the process of getting a sense of, we have a construct, can we define it and understand what its factors are, and then building from that, getting a sense of how much of the variance is explained through this factor structure. And that really allowed us to build into our understanding of psychometric instrument development. So we ask ourselves, what is the concept I'm trying to measure? And that's really the core question that you need to reflect on. And just because something has been measured in the past or is published in research doesn't necessarily mean that that's the best measure, nor does it mean that that measure adequately measures what you think it measures. So sorry, I've used that word too much. But you want to brainstorm possible indicators of the concept, define it, draft measurement items, and the key step is to pre-test and pilot test them, examine the psychometric properties, and redraft and retest them. So these are all key components of when we're developing our tools in psychometric instrument development. Now, we spent a lot of time talking about measurement error because it's one of these factors that can really influence our interpretation of results and may lead us astray. So measurement error is really the deviation of a measure from the true score, and the sources can be non-sampling. So for example, the paradigm itself, respondent bias or researcher bias, or sampling, non-representativeness of sampling. So there's a lot of non-sampling and sampling related contributions to sources of bias or measurement error. And to minimize measurement error, how can we do this? Well, we ensure that we're using well-designed measures. We ensure that our samples are representative and we maximize the response rates of our data collection. We reduce the demand effects and ensure administrative accuracy when entering data. And so at every step from conceptualization to data inputting, there are potential ways in which error can be introduced into your study and your analyses. And so we want to ensure that we're conscious of it at every stage and trying to minimize it as much as possible. And we talked a lot about reliability and validity. Reliability is about the consistency. So when I say reliability, you should be thinking repeatability. So in the sense of consistency of the items within the measure, so how the items are actually measuring the same construct, and the measure over time. When you measure something over time, is it measuring the same thing? And validity is about whether the measure actually measures what it's intended to measure. Are you testing what you mean to test? That's the fundamental of validity. And in terms of survey research and design for our measures, it's our measures measuring what it actually is intended to measure. If you have a better way for me to structure that sentence, please let me know, but hopefully it makes sense. And then we built from our massive exploratory factor analysis and psychometrics topic into multiple linear regression analyses, because we learned this beautiful thing that occurs, which is that once you have a factor and you can analyze internal reliability, you can actually compute composite scores and you can treat it as you would any other variable. So you could have a factor of openness and then you create composite score, and then now it becomes a measure that you can use in subsequent analyses. And you can use it in multiple linear regression analyses. And so in that, the steps we take for doing a multiple linear regression are really analogous to the steps you take in many other analyses as well. You start by, in this case, you develop a model and you have a hypothesis, you check your assumptions, but here you choose your type of multiple linear regression analyses, you interpret the output, and you can develop a regression equation if it's needed within the context of the purpose of what you're doing. And so hopefully this figure is sort of etched in your brain when you think of any regression. And so linear regression is best fitting straight line for a scatter plot of two variables. And here you can see the response and the predictor. So the dependent variable, the response is on the y-axis, the predictor is on the x-axis. And what we can see here is our red line is our slope, really. And so what we want to see here is these are our data points, and this is the error. And here, through this error, is how I introduced you to the concept of what we mean when we talk about variance and standard deviation. And so here, we're trying to minimize this error, right? That's in this model, but it's very rare that you're going to have all the dots fit onto the line, and so there's always sources of error that's there, and that's the gray bit here. And so we have to understand what this is and quantify it and try to see if we can account for or explain it. And so multiple linear regression analyses uses multiple independent variables to predict a single dependent variable. Why? Well, because when we're asking the questions of saying, what is the relationship between coffee consumption and happiness? You may find that people who drink coffee are more likely to be happier than people who don't drink coffee. These are fictitious data, as I'm sure you're aware. It's not based on any real research. But I may ask you the question based on what you've just proposed. I may say to you, well, how do you know it's the fact that they drink coffee that is associated with their increased levels of happiness, and not that maybe when they have a coffee, they're more likely to be having a coffee with someone, or maybe walking to get their coffee, or it's not the social factor or the physical activity, or maybe even the physiological effects that we see in relation to these things that is linked to the increases in dopamine and happiness feelings. How do you know it's not that rather than the effect of just drinking coffee? And then you may say, well, I thought of these things, and so I ensured I controlled for these variables by including them in the model. And so this allows us to have multiple independent variables in the model to predict a single dependent variable. And we could say this is the association between coffee consumption and happiness after controlling for physical activity, after controlling for social interaction. And so the overall fit and coefficients we look at as well through the coefficient of the overall fit through the model fit, and coefficients that we look at for the effects. And there are three types that we looked at, which was standard, where everything is inputted into the model at once; hierarchical, where we build the model progressively, and we're asking a slightly different question of how much additional variance is accounted for by these variables or sets of variables in the initial model; and then stepwise, which is where we're sort of allowing a computer to make a selection as to what gets included or removed from the model. And then we built on this understanding of multiple linear regression by talking about semi-partial correlations in multiple linear regression, which can be used to get indicate the percentage of variance in the dependent variable that's uniquely explained by the independent variable. So it's in typical analyses, we're looking at the shared variance, but in semi-partial correlations, you get a sense of the individual variance of variables. So we can compare each semi-partial correlation squared with the R squared, or SR with the SR. And if they differ, we can think about why this might be the case. If it stays the same, there may be no overlap between the predictors. So if it drops substantially, then there's possibly a strong relationship between the predictors. If it's 100%, we know that those predictors are essentially measuring the same thing. So the information that we get from semi-partial correlations is important for the individual predictor to say how much of the variance is accounted for by this uniquely by this individual predictor, but also gives us an indicator of its change when we look at it between semi-partial correlations and normal correlations, not normal, but correlations. We get a sense as to change in the relationships between predictors as well. And then we talked about interaction effects. In multiple linear regression, independent variables may interact to have no effect, increase the independent variable's effect on the dependent variable, or decrease the independent variable's effect on the dependent variable. And so we talked about interactions in the sense of, in plain English, how the relationship between an independent variable and dependent variable depends on something else. So for example, the relationship between student happiness and conducting statistical analyses maybe depends on the level of expertise that they've gained through the course. And maybe you see that maybe there's no correlation between student happiness and statistical expertise. Student happiness and conducting statistics, but you find that actually this relationship depends on student expertise, whereby those with more expertise are more likely to be happier than those with less expertise. Again, fake data, but it's just a sense to give you a sense of interaction effects. So model interactions using hierarchical multiple linear regression. You can enter the independent variables in step 1, and step 2, you enter the interaction effect, which is also called cross product, because we saw in the equation that an interaction is really a multiplicative effect. We're multiplying the effects of the two variables together. And examine the change in R squared. See, does it change? Is there more variance accounted for by the presence of the interaction? And then we talked about analysis of change. So change over time can be assessed either by a standard regression, where you calculate differences in the scores, so post score minus the pre-score. If you're doing a test, say cognitive test, you're doing post-test and pre-test at different time points and use it as a dependent variable, but doesn't tell you how much additional variance is accounted for by the independent variable over and above the baseline dependent variable. So this is where we had techniques like we partialed out the baseline score through the regression, or we enter other independent variables as well to help predict variance and changes over time. So we had these different ways of through a hierarchical multiple linear regression to be able to get a sense as to the change over time and how much additional variance is accounted for by independent variables. And then we built from all of this into our power and effect sizes. So we talked about significance testing, the logic. So at what point do you reject the null hypothesis, and how it started in the 1920s and became very popular through the second half of the 20th century. And the criticisms are that it's binary, again, reinforcing that there's no such thing as saying that it's highly significant or slightly or almost significant. It's a binary test of whether it is or is not. And it's dependent on sample size. The more sample you have, the greater your power to detect an effect. Effect size and critical alpha. And practical significance. So is an effect noticeable? Is it valued? And how does it compare with benchmarks? So this practical significance, also called clinical significance, is not talked about enough in the research, and is really something I hope you walk away with from this course. Always asking people about, okay, I see that it's statistically significant effect. How big was the effect? What does this mean for someone? Would you recommend that someone engages in this behavior as a result of these effects? And we see this all the time in research for brain health in dementia as well. Say you see some diet intervention, or say even the consumption of alcohol, there's mixed effects in terms of red wine is good for you, it's bad for you. And then if you press a scientist and researcher and you say, well, actually, what is the contribution of alcohol to brain health? Should I drink some red wine? On aggregate, most people will say, well, the size of the effect is small and the risks outweigh the benefits. So on aggregate, probably not drinking is better, much better for your brain health than even drinking some or a lot, or definitely not a lot, but some types of red wine. But the importance of getting to the nuance of that discussion is that you may find people who disagree with that statement, and they may have justifications for that. And the core is, what does the data say? And how does the justification land from the data to the inference that's made? And that's where the argument for practical or clinical significance comes from. So, for example, my justification for saying that alcohol consumption, if I was to advise someone in the population what to do for their brain health, often I say, don't smoke and don't drink. And if you do any of those things, just be aware of the contribution. And if you smoke, try to reduce or mitigate your smoking. And if you're drinking, drink in a way that you understand what you're informed of the decisions you make in as you progress in your life. And so the focus of research is to help people be more informed in the decisions that they take and make, so that they can modify their behaviors or choose to continue in behaviors, but understand the risks associated with them. And so that's really where practical and clinical significance comes to. And effect sizes, which is a standardized difference or strength of relationship, it comes down to fundamentally the effect that you're looking at. How is it measured and quantified? And we talked about all different things could be effect sizes. If you're looking at the mean difference in weight between people of two groups, then that could be an effect size. You can standardize it to get a strength of the relationship. An inferential test should be accompanied by effect sizes and confidence intervals, so that you get a level of measurement error or precision around the measurement, but keeping in mind that in frequentist statistics, the confidence interval, we talked about what that means in the sense of if you were to sample 100 times in the exact same way, in the exact same conditions, and 95 of these confidence intervals would contain the true population effect. And then common bivariate effect sizes include Cohen's d and correlation, but it could also be your beta that you use, your standardized beta from your models, or your unstandardized beta, but it requires nuance of interpretation. There's many effect sizes that are there, but these are bivariate effect sizes that we see. And what is going wrong in psychology, or even more broadly in science? Publication bias. There's the tendency for studies with statistically significant findings to be published more often. Replication crises, where people are not valuing the use of replication studies, and so it's not done as much. But I showed how there are ways in which it can be done through repeating studies, but then building on those findings to add something new. And then academic integrity issues. Almost every day there's some integrity issues that are occurring, and Retraction Watch is, I get emails from Retraction Watch because I've signed up to and keep on top of what is getting removed from the field, because you have to be aware of the fact that if you're citing evidence and you're not aware as to whether or not that evidence has been retracted, then you could be adding to the problem that's occurring in terms of the paper being published and retracted. It still has influences beyond that. And so many software managers such as Zotero, and there's EndNote as well, but I use Zotero because it's free and it integrates with R really nicely. And what I notice in Zotero is it actually flags papers that have been retracted. So it says, warning, this paper has been retracted. Have you seen this link to the retraction notice? And so I think systems and processes in place are getting better so that people are more aware of what's retracted and when. And so tying it all together, I think the big question from all of this, we've gone through so much research together, is thinking to yourself, well, with this power comes what responsibility, and what sort of responsibility do I instill upon myself as a researcher, and what kind of researcher do you want to be? There are really a lot of how we attribute our values in research. There are some consensus standards and goals that people set, but largely it's driven by individuals and by teams and labs. And so I sort of gravitate towards labs that hold the values of transparency, openness, critical thinking, willingness to help support people learn. I think that's what I try to instill in my own lab as well. So the researcher I hope to be is one that is investigating issues that have an impact on others, and does so in a way that allows the conclusions to be drawn from that to be meaningfully interpreted by the person on the street that I talk to. And so every day I get asked, because when I'm meeting people or talking to people about, and I say I'm a neuroscientist, I look at these risk factors and their contribution to brain health and all these other areas, I get asked, what do I do to help preserve my brain health? Or how do I prevent my risk of dementia? And for me, part of being a scientist and researcher is synthesizing the evidence and making it digestible for someone to be able to inform their life moving forward based on the findings there. And so the kind of researcher that you want to be, maybe you're a researcher who really values openness and transparency. Maybe you're a researcher who really wants to be collaborative, and I would highly encourage you to be so, because much of the joy of research comes from collaboration. But really think about this question, because there will be times where your morals and your ethics as a researcher are tested. And much of research, whilst it's changing over time, a lot of research can happen behind closed doors. And so the the marker of what I think is a good researcher is one who is able to open those doors and say, hey, come on in. You can see everything that's here. This is how I've done it. If I've done something wrong or incorrect, let me know. I'm happy to improve, and we can build from this process together. But I welcome to, and I'm sharing of my resources. But I think in your careers, if you progress into research, you will constantly find the pulls and the tugs of pressure in relation to the pressure to publish, the pressure to obtain funding, and many others. And so if you don't have a good considered thought about this question of what kind of research you want to be, what your values, morals, and ethics will be, particularly in the age of AI, then you may find that you encounter challenges later on, or you fall down slippery slopes, or behaviors and patterns that don't service the field of research, and fundamentally won't help people in their day-to-day lives. And so I think these are really important questions, and I hope you reflect on them. And when we're tying it all together of everything you've learned in this course, I want you to think about what you've learned in this course through when you're reading either articles and journals, news sites, or what's shared on social media. There's a lot of health influencers on social media, a lot of big claims that are made, which the justification itself seems logical until you try to say, well, what's the evidence that's there? What are the papers that support that finding? Is there any evidence? And so ensuring that you have the critical lens that you've developed, and then probing. Just because there's a paper on a topic doesn't mean that paper, and because it's published doesn't necessarily mean that paper is supporting the conclusions that are made from that paper. The navigating the biases that can occur in the research process. And so when you're working or preparing summaries or reports or evaluating a program or making graphs or infographics, ask yourself, how can I make this transparent? How can I make sure that the core messages are there? Or where I'm making conclusions, I acknowledge alternative conclusions that may be the case, and provide justifications for why the conclusion is what I'm stating it to be. And when you need to prove a point, you now know the skills of searching the literature and using that evidence to support your evidence, and support the claims that are being made, or maybe even to shine a light on the available evidence to note what is there and what's a gap, or maybe it's mixed evidence, and what justification you have from the literature to pull together your conclusions. And when you're filling in a survey or a poll, or interpreting the results of them, and you hear these political polls that are there, ask yourself, who was sampled at the very least? Who was sampled? What were the questions? How were they asked? Was it standardized? All these sort of factors that you now know that you can take forward. And fundamentally, when making important decisions, what does the evidence say I should do? Or when people are asking you to make decisions, hopefully the critical lens that you've developed through this course serves you well in your careers. I think one of the joys I've had from learning statistics and teaching statistics is the flourishing of critical thinking that occurs through that lens and framework. And so hopefully you've experienced some of it, or you continue to experience it, and hopefully there's a little bit of a love for statistics by the end of this course, and appreciation for what it does, what it allows us to do, and also an awareness of its strengths and its limitations, particularly in how it can be misused or misrepresented. And so in saying that, I guess all that's left is to say thank you and good luck. I love teaching. That's probably no surprise to you. But really what makes teaching a rewarding profession for me is the students. So you are sort of what is unique about this course every time I teach it, and it is relationships with students that make teaching a meaningful profession for me. So I thank you for your contributions, your efforts, and the time and effort you've put through to this course. And I hope in return you've felt that you've not only learned something, but maybe you have a bit of a love for statistics, or maybe you'll think back fondly on some of the stories or lessons learned through this course series when you move forward in the world, and say, actually, is this necessarily is the way it's being presented necessarily the way it is and the way it truly is to be. And so that critical lens is hopefully instilled upon you there. But in saying that, please keep in touch. I'd love to hear how you go forth in your careers through my email address, anandin.ambikaraja@canberra.edu.au. I'd love to hear how you progress in your fields, and yeah, just all the best. I wish you all the very best, and thank you for all the work you've done for this course. So thank you very much, guys. I'll see you.